Hello everyone. So in this video we're going to see the problem A and problem B of Codeforces round 686 division 3. Both of them were pretty simple problems. So let's see. So the first problem is special permutation. So we're given one integer n and n is greater than 1. So what is a permutation? A permutation is of length n is an array consisting of n distinct integers from 1 to n in any order. So 2, 3, 1, 5, 4 is a permutation because from 1 to 5 every number is there, but 122 is not a permutation because 2 appears twice, and 134 is also not permutation because n is 3, so it should be 123, but 4 is there. Okay, so we have to find the permutation p of length n such that at no index I p of I is equal to I. So what does that mean? So pretty simple. All that means is that suppose we have n is equal to 5, so that means that we need to find a permutation of length 5. So permutation can be 1 2 3 4 5 in any order. So what are the indexes? So indexes are 1 2 3 4 5. So the element at 1 should not be equal to its index. So here you can see that all the indexes are equal to their elements, so it should not be the case. So what can we do? So we can say 2 1, and then we can say 5 3 4. So in this permutation you can see that no element is equal to its index. So 2 is not equal to 1, 1 is not equal to 2, 5 is not equal to 3, and so on. And for example, n is equal to 6. So the indexes are 1 2 3 4 5 6. And so what do we need to do? So we need to make it in such a way so that no index is equal to its own element. So 6 5 4 3 2 1. So in this you can see that 6 is not equal to 1, 5 is not equal to 2, 4 is not equal to 3, and likewise. So my point is, so you can divide the question in two ways. If n is divisible by 2, so if n is divisible by 2, then no problem, you can just simply print 1 to n, or let's say print n to 1. So basically all the elements from 1 to n you're printing in decreasing order. So we already took one example, but let's take another example. So suppose n is given 8. So n is divisible by 2. So all you need to do is just write 8 7 6 5 4 3 2 1, and the indexes are 1 2 3 4 5 6 7 8. So what does it show? So 8 is not equal to 1, 7 is not equal to 3, 6 is not equal to 4. So no element is equal to its index. But this will not work if n is odd. So if n is equal to 7, then you will have 7 6 5 4 3 2 1, and 1 2 3 4 5 6 7. So you can see that the middle element is equal to its index. So idea is simple. For n being even, all you have to do is just print it in reverse order. And if n is odd, then what are we going to do is, it's pretty simple. So what we're going to do is just we're going to take the numbers from 1 to 7, and except the last three elements, we're gonna keep swapping all the pairs. So we're gonna leave the last three elements, and then we're gonna swap all the pairs. So leaving the last three elements, we're gonna swap 1 and 2, so it'll be 2 and 1. We're gonna swap 4 and 3, so it'll be 4 and 3. Then we're gonna swap. So now these three elements are remaining. So how we're gonna swap this is we're gonna swap this and this. So this will be 7, and this will be 5, and then we're gonna swap 6 and 5. So this is gonna be 5, and this is gonna be 6. So 1 2 3 4 5 6 7. So you can see that no element is equal to its index. So if you still didn't understand what we're doing, I'll just get to the code. So basically we're seeing if n is even. If n is even, we're just printing n to 1, and if n is odd, then let's see what we're doing. So this is my submission, and this is my submission. So you can see that if n is even, then what I'm doing is from n to 1, I'm just printing all the numbers, not a problem. But if it is not, then I'm storing 1 to n in an array A, and then till n minus 3, I'm gonna swap all the pairs. And then finally what I'm doing is I'm swapping the last element with the third last element, then the last element with the second last element, and then I'm printing the result, and that will give me the answer that I want. So that is it for the first problem, pretty simple. If you have any doubts, just look at the code and you can ask it in the comments as well. So the second problem is also very simple. So the second problem states that there are n participants, and the ith participant chose the number AI. So the ith participant chose the number AI, and the winner of the game is such that the participant that the number he chose is unique and is minimal. So the number chosen by a participant should be unique and should be minimal, and then that participant will win. And if there is no winner, then the answer will be -1, indexing in 1 based. So if you did not understand the question, just read it once again. It's pretty simple. So let's look at some example. So 1 1. So let me just remove this. Okay. So 1 1. So in 1 1 you can see that no answer is unique, and so basically there won't be answer. So answer is -1. And then we have 2 1 3. 2 1 3. So you can see that the minimal unique answer is 1. So what is the index? 1 2 3. The index is 2. So answer will be 2. So basically what we're doing is we're finding the minimal unique element, or basically the smallest unique element we're finding in the array. That is it. So for example, let's take another test case, 2 2 2 2 3. Okay, so we have 2 2 2 2 3. So 2 is not unique, so we can just leave that. The next minimum element which is unique is 3, and its index is 4. So the answer is 4. And then you can take this example, 2 3 2 4 2. So here we go. So 2 in increasing order, the lowest element we have is 2, but it is not unique, so we leave it. Then we have 3. 3 is unique. So the participant which gave 3 wins, meaning the index of the 3 is the answer. And here the answer is 2, which is the index of 3. And you can see that the answer is 2. So that is what we're doing. Basically, we're finding the minimal unique element. So pretty simple, just an implementation problem, because Div3 are for pure beginners. So, but still, let me just get over the code. Okay, so all I'm doing is I'm taking in the input of the array, then I'm storing the vector. So in the vector, I'm storing all the unique elements in ascending order, and then I'm creating a map to count the frequency of all the elements. So whenever I'm finding the element for the first time, I'm storing it in the vector, and if I'm finding it again, I'm not storing it. So the vector will have the unique elements, okay, and I'm counting the frequency of each element in map. Then I sorted the vector. So for example, if I have 2 2 2 2 3, so the vector will have 2 and 3. Now I look at 2 and I see, is its frequency 1? Because in ascending order, I want to find the first element which is unique. So that's why I'm going in ascending order in the vector which has all the elements. And if the frequency is 1, meaning the element is unique, then that will be my answer. However, if answer is -1, then I'm just printing that. Otherwise, I'm going to my array and seeing where the answer's index is, where the answer is in the array, and I+1, meaning that index, will be my answer. So going once again, all I'm doing is I'm showing the frequency of all the elements in a map, and I'm storing the unique elements of the array in a vector, and then in the vector, going in ascending order, I'm seeing which is the first element, meaning which is the smallest element, such that its frequency is 1, such that it is unique, and that element, I'm finding its position in our array, and that will be the answer. So this is it, both A and B, which are pretty simple problems, and so that's it.